into the Energy Tech Podcast. I'm your co-host, Mike Flores, right here in sunny San Diego, California, as part of Ignition Inductive Automation's Solar and Battery Discovery Day. And it's great to have a guest. I was going to have him later today, but we fit him in right now, Mr. Mike Freedman, the co-founder and CTO of Tiger Data. Good to have you, Mike, on the show.
Thanks for having me.
Yeah, it's good to be here, and I'm glad you made it. You know, and I want to start off real quick with what brought you to this point to kick off Tiger Data as the co-founder. I want you to talk about that, and then right after that, I want you to share a little bit about the connection with inductive automation and ignition and a partnership with TimescaleDB.
Yep. So Tiger Data, we're the creators of TimescaleDB, which is an open source database built on Postgres, which is a very popular kind of relational database.
Right.
We launched initially in 2017. We've been around for almost 9 years, millions of deployments worldwide. Now what's interesting is when we started back in 2017, it was to serve the industrial IoT space. We saw the rise of all these IoT devices generating a lot of data. And the question is, do we need a new data platform for that? And that ultimately became TimescaleDB. Fast forward a number of years, we have a fairly large business serving in the cloud, but we still see ourselves constantly deployed, both people storing data in the cloud, but constantly deploying us also on-premise. And by on-premise, I don't just mean like in a private data center. In fact, I mean on the factory floor, in a mine, on an oil rig, on the trucks near fracking sites, in solar, in battery sites, because the data needs to be next to the equipment. And in many of those places, we've seen as early as 2019, people were connecting us to Ignition. And that Ignition became the kind of real-time platform for collecting data, visualizing it, but they need a good place to store it. And the existing relational database, existing historians don't really do that well. And so they needed a new modern solution like TimescaleDB, which really allowed them to scale and connect that with all the other business data that they had. And that really turned out to be why we saw this broad adoption across many areas of the industry, even though it wasn't something that we were as closely focusing on as a business. As you mentioned earlier this year, we finally recognized you keep feeling your actually community pulling you into an area. And we said rather than just people off the shelf connecting Ignition and TimescaleDB together, let's actually kind of build that partnership with inductive automation so that these things could get actually a much better solution brought together. And that's what we're excited to do. That's why I'm here at Solar and BESS Discovery Day. We see lots of deployments in TimescaleDB in the solar industry, in the battery storage industry. And I'm really here to talk about what are the good architectures for that, and what are the right technologies that allow these systems to scale.
Yeah, so let's go to that. So, there's an architectural reason for that, and I want you to kind of discuss that real quick. Just what that entails, because it's more than just when I think of timescale, you're right. I don't put you in the categories of just a standard time series database, okay? Yep. So I think you guys have served a real great purpose, and you're right in that operators want to continue to maintain that control. They want to have that data as close as they can, not just to the plant, but to the edge, right? That's another piece. And after you talk about that, I want to ask you this. You are seeing the rise of a unified namespace, which is I'm taking that data from the edge. I want that pipeline. I'm going to leverage things like MQTT. And as we know in the same space, Mike, there's this growth now where we want that streaming data. And where does TimescaleDB fit in terms of streaming data across that same unified namespace pipeline?
Yeah. So I'm going to talk about this a little bit later today in my talk, but really when I think about what is the operational data platform that you want for these systems. So again, Ignition becomes a standard for figuring out how to talk to all these kind of existing old school industrial protocols, bring it over to the IT side so you could use it. But there's really 5 requirements I talk about, and some of them get to what you talk about with a traditional time series database, and some also bring more into the unified namespace and other things that kind of we uniquely can do. And those are, you need to be able to support high rates of data ingest. You have you have millions of tags. You need to be able to store that data economically and efficiently because there's a lot of data and it keeps piling up. You need to be able to query the whole thing quickly. So it's not just can you store it, can you actually do visualizations? Can you provide those dashboards in real time, in history, and all these things? You want to need to handle late arriving data. This is something that a lot of people don't think about. You know, the world is messy. Your devices are battery backed. They only power up a couple times a day. You bring new systems up, you need to backfill years. You need to write a lot of data, and you need to connect it to context. And so what I mean by context is it's not just about the tags alone. It is about the asset model. It is about other business context. It's about, pulling in weather data, lots of different sources of data. And the thing is, historically, a lot of times you actually had 3 different systems to do that. You had your time series database, you had your business data or ERP or something else.
Or an industrial historian somewhere.
Or an industrial historian, or something else for your asset model, your graphical database.
Right.
And what that meant is you had to maintain 2 or 3 separate systems, and you had to write application code that stitches them all together. And anytime you want more insights, it's a whole process, and you're really limited. And again, with TimescaleDB, because we combine those time series and the business and relational data in one database, it's just a join in the database. And so you could do that from Ignition, you could do that from your existing BI tools, you could do that from any type of applications that could speak SQL. It will just work out of the box. And that's been a big boon to simplify operations, but also to, accelerate the kind of business questions and the business values you could unlock from that data.
How do you add more value when it comes to, you have 2 types. One of the things I'm seeing right now in the industry is the cost of cloud and tokenization. You want to reduce that cost, so you are seeing the rise of, you mentioned it earlier, it might be a VPC, or it might be something that I want to do where I've got my own NVIDIA store and I want to hold on to that. It sounds like there's some capability there for TimescaleDB to function, whether you continue to be a traditional cloud customer, or you said, hey, I really am looking at not just my cost on tokens for AI, but I want to localize that, right?
Yeah. No, it's a great question. So there's really 3 ways people could deploy TimescaleDB today. One is they could use the open source. They could deploy it anywhere they want. The other one is they could use our fully managed cloud running on all the hyperscalers. We have thousands of industrial customers doing that today.
Right.
And the third, which we actually announced just a couple months ago, was our TimescaleDB Enterprise, which is actually kind of the full-featured versions with high availability, with backups, with operations, with monitoring, with AI enablement for people to deploy this on their site. One of the interesting things that we've also seen is it's not often either or. Unlike, let's say, a lot of web systems where you have one database, a lot of times here the data has to be where it's generated. So we see a lot of people who take a hybrid architecture, they deploy TimescaleDB on the sites, and they also have an aggregation layer in the cloud that actually serves as the enterprise level visibility. Or they just build that aggregation layer in their own infrastructure as well.
Right.
And so again, we see a lot of deployments where it's not just one database, but it's kind of this data architecture that follows their operational deployments. And that's been very powerful. You mentioned tokens. I completely see this movement from, look, we're happily burning a lot of tokens for all the kind of AI models.
Right.
Now it's a little bit time people are starting to ask, what is the ROI I'm getting about spending those tokens?
Right.
We're doing a lot of things with smarter model collection and model selection, so you don't always burn the most expensive things. But I definitely see a movement also to local deployments with local models, open source models, kind of sovereign, your own sovereign GPU clusters. And so we're starting to do that. And the good thing, again, because this is a traditional relational database, your model today knows how to use Timescale. If you ask your model, they will be able to query it pristinely.
I wouldn't call you guys traditional. I think it's a capabilities tool, right?
Well, I use traditional in the sense that we speak standard protocols. So the models have been so carefully trained to know how to speak SQL, which is not the case if you bring up this arbitrary UI that speaks these proprietary protocols.
Unstructured pieces. Yeah, absolutely. Yeah. So, in terms of aggregation, you talked about that, but what about on the side where you have customers that are, right now you have democratization or deployment of applications in a lot of different scenarios. It could be a cloud backend application. You have the ones that run simple to Firebase type applications. Where does TimescaleDB fit in that scenario where someone is looking at deployment of applications that are not just standard ignition perspective, right? Like,
Yeah.
where do you think that fits?
So I think there's a couple different ways to take that. Generally speaking, databases power most applications today, and we obviously focus on those who generate a lot of data, and typically of the form it has some type of event-based sensor data, time series based. So that's has been our bread and butter. Even though, from our cloud perspective, we're also offering effectively a managed Postgres architecture. There's a lot of things that we've done. Again, this a little bit more is in the cloud because we could build a level of automation that's harder when you're deploying individual pieces of software. But we've built a lot of things to allow people to automatically spin up for kind of agentic applications. You could have agents that automatically could spin up full stack applications, easily fork data. There's a lot of interesting stuff we're doing with kind of storage architectures in the cloud where, hey, if you want to give an agent a copy of data, you could, within seconds fork your entire database due to some like underlying technologies we've built, do changes, whatever. But I do think, broadly speaking, the exciting part of this is it allows people who don't even come from a traditional software engineering background to then take better, make better use of their data because they could actually, help develop it with the use of AI.
So what I'm hearing is you can have the complex, structure as code person, those CI/CD pipeline folks that are doing complex or agentic work, and then you have those that are what you would term as, hey, they're traditional. They can see a lot of those capabilities right away.
Yeah.
Right. I think. Let me ask you this. It also sounds like you've got some capabilities surrounding people that are leveraging like MCP flavors and things like that, right?
Yeah. So we ship with Tiger MCP. It allows you to like program against your database. And in general, the thing that came after it, AI is moving very fast. MCP is probably even like on the trailing out. There's more agent skills we could bring in. You build in CLIs where it could call those things directly while using less tokens. So a lot of stuff that we've made it very easy for people to do agentic development and also use agents to actually understand their data. And that's what I was talking about with local, because I think there's also that interesting part, which is how do you actually could now with local models start deploying those things on the edge. So the agents can run on the edge, use local models, use local compute, use local GPU, and use local data.
Yeah.
And that allows you to like have that level of site resilience, but also when there's security compliance that people worry about, that could actually bring a big. We see that as a big area of growth for us actually to help these industrial applications. Yeah.
Yeah. One of the things we're seeing that in working in the same space is the leveraging of alarm management data there at the site, right? Making recommendations. Not necessarily supplanting an operator, but recommendations in that case.
Yeah, so we see so it's interesting. We see this, one of the places that we're using AI as our own company is that, we run a large platform team. We run literally hundreds of thousands of containers in the cloud. So we're talking about, some real scale. And obviously with a platform team, you have to automate the heck out of things. Yeah. But also, there's a long tail of questions. So one of the places we're using AI is actually using AI to help do, as the replacement for the old school of alarm for run books. Yes. When alarms come, how do you actually analyze lots of data in real time at 3 in the morning to try to quickly explain why something has happened and give the operator then more visibility? Well, that is about managing a cloud platform, but those same type of practices actually apply to managing physical infrastructure. Yeah. So I think that one of the areas of practices underexplored is how kind of this agentic explanation will actually help humans operate these type of critical infrastructure.
Well, I think you're right, because it goes beyond just alarm data or what we call an ISA 18.2 model. You have operators that are actually typing in notes and collecting information, and you want to take that semantic information, aggregate that, and create a recommendation.
So one of the things most people know us as TimescaleDB. Yeah. One of the reasons we changed our name, for many years we're known as Timescale, we rebranded a year ago to Tiger Data, is because we saw us tackling more problems than just time series data. Yes. And one of them was around AI data. So if you look at the Postgres search stack, there's a lot you talked about using semantic data, vector search, keyword search was known as hybrid search. We've actually built most of that stuff for Postgres. So PG vector scale, PG keywords, PG text search, those were all built by
RAG
Tiger
integrated,
Data.
yes.
Exactly. Yeah. And so why that touches what you said is like, it's not just about why this alarm goes off. You want to look at the alarms, look at the semantics of the alarms. You want to actually bring in your time series data around that and anomalies, try to explain it. You want to bring in your asset framework to explain what type of site does this belong to. But you also want to do RAG against your technical specification.
Absolutely.
And you want to do this all at one time, and that's really, I think, a powerful area that there's still a lot of innovation to do, but it's ultimately going to be about how we run at fleet scale. One of my talk today was talking about from assets to fleets, and it's about shifting your thinking from how do I protect this one, precious thing that is the singular factory,
right,
to managing at aggregate capacity. If I have 10,000 items that are all identical, it is probably the case that they all will. The one thing about with the cloud, something is always going wrong, and so it becomes about operating at aggregate capacity rather than trying to operate the one singular thing. And so I think a lot of the ways you think about operations change.
Mike, a couple of things I want to ask you. Give me a sneak peek about what you hope the audience takes away from your talk today.
Sure. I think there's two main things. One is obviously a better understanding of what the data needs are. Yeah. When I look across the industry, the most common thing I hear is, oh yeah, we use SQL Server because an IT department brought it in. And so people are using 30-year-old technology that was never designed for what they wanted for.
Right.
And so one is to better understanding what are these 5 things as we're, again, moving from singular to fleet scale. We have more tags, more velocity. We need to think, how do we evolve our data infrastructure? And the second part is to think about all the different types of deployments that we actually have. We've seen now across a lot of our users, single site deployments, large hierarchical deployments. When we're talking about AI factories, these are crazy scale. We're talking about multi-site with enterprise level visibility. We're talking about distributed edge. We have lots of virtual power plants, distributed energy, pipeline operations, lots of really tiny edge gateways that go to a central point. So there's lots of different types of deployments, and I want people to better understand how you can deploy data infrastructure in these type of different configurations.
How does someone work with Tiger Data? One of the 3 main areas that I target, especially when it comes to folks like Tiger Data, is cost, complexity, and cyber. So you already talked about the entire cost. You talked about complexity, and actually you talked about cyber. In terms of complexity, someone wants to get started, and they're not a huge operator. They sit right in the center of that. How do they get started? Yeah,
so there's 2 simple ways. One, they have to decide, are they in the cloud or not? If they're in the cloud, click a button, you have a database running in 3 minutes. Couldn't be easy. We handle the security, we handle the cyber, we handle, and you have our support and operations team always standing by. 24/7 follow the sun. If you need to be on site, right, we will, like I said, timescale the enterprise, it will be download a Docker container for control plane, click a couple buttons, we will install it, we will manage it, we'll do HA, we'll do upgrades. And so it kind of brings the power of the managed cloud now to your site.
Yes.
And what's the third thing is, part of this is also what we call live sync or cloud sync. So we have the ability to now, again, with a click of a button, you could have your data at different sites and we will replicate it live streaming elsewhere. So if you actually want to have 4 sites up to the cloud, click a button, there's a server in each of your 4 sites, and then immediately we'll streaming live to the cloud so you can have visibility there as well. So I think it's really trying to bring, we're not OT people, we're not experts in solar and BESS and other industries. We know that's what the SIs are, that's what the operators are, that's what the ISOs are. But we could bring a lot of IT and computer science, systems engineering background to it.
Well, what I'm hearing, Mike, from you and Tiger Data is that you enable data for folks that are at BESS or anyone else that's in the space, especially industrial space or industrial automation, right? I think you'll do that. Is your team going to be at ICC this year?
We will be. We'll be there in presence.
Awesome. Then you can catch us there because I want to do a part 2 with you if I can. This is a selfish plug for us.
Look forward to it.
We will be there at ICC, and with that, I don't want to let him go, but I have to. With us, Mr. Mike Freedman, the co-founder, CTO of Tiger Data, right here on the Energy Tech Podcast. It was great to have you on the show, Mike, and I'm your co-host, Michael Flores, with the Energy Tech Podcast. Don't forget to like and subscribe right here. We're in sunny San Diego, California, with the Energy Tech Podcast. Thanks again, Mike.
Thanks.
It was good to have you.
See you at ICC.
Yes.